Okay, so now yesterday just in the first slide I just started with 8051 microcontroller. So in the first chapter we'll be dealing with your 8051 microcontroller. Okay, so here what is the role of a microcontroller? So what is the objective of microcontroller, or what is the role of microcontroller when we go for a dealing? Yesterday's class in the outline we learned. So here in chapter 1 we will be focusing on 8051. 8051 is the currently available microcontroller in the market. It's available. So depends on the usage. We can have our own microcontroller chip from the market, and we can go ahead for further usage. So microcontroller is a single chip or microcomputer made through VLSI fabrication. First point is microcontroller is a single chip. It's a chip oriented design, or micro. It is in a micro level 10 power minus 6. Nano means 10 power minus 9. These all parameters you all know that. So made through VLSI. What is VLSI? Very large scale integration. So now, earlier small scale integration people have designed, but nowadays people rely much on very large scale integration of fabrication. This VLSI fabrication and other fabrication things you have learned, I hope, 1 year back in your linear integrated circuits. There you have made IC fabrication, etching, and then vaporization. All those things you have learned already in a basic manner. Okay. So here, remember in your mind, the first point will be microcontroller is a single chip and of microcomputer made through VLSI fabrication. Second one, microcontroller is also called as embedded controller. As I told you yesterday, we have discussed in Unit 1 microcontroller, second chapter ARM controller, then third followed by we will go for with advanced microcontrollers, and finally embedded controller. Embedded is a tool. So here by using a embedded system, by coding the microcontroller in a programmed way, so that your microcontroller will be modified according to your usage and your necessity. So here microcontroller is also called an embedded controller. Don't confuse that, because the microcontroller and its support circuits are often built into embedded and the device may control. So here devices may have a set of circuits, you may have support circuits, many things you may have, but all these things are built together in a single chip. You may have a single chip. That single chip will play means a lot and will speak a lot. That meaning will be different. Each pin, what is the role, and which pin we are supposed to use, which port we are supposed to consider, and all those things. It may be appeared into a single chip, but meaning will be enormous, right, to understand. And that's what we used to call it as what micro. The name itself, controller, you all know that controller is a device which is inserted into the system to modify the system for better control action. Control may be input side control or output side control or a process control maybe. That's what we discussed yesterday. So here we particularly focused much on micro. So in the form of 10 power 6, and it is amicable, and it will cost base oriented, and occupying the space, and these all the things are the advantage. Then the third point will be microcontroller is available in different word length like microprocessor. See, maybe you have learned the microprocessor and the digital system 1 year back. I hope you remember. Microprocessor is the microcontroller is advanced for the microprocessor, and the microprocessor is a programmable logic device. So here also it's a programmable logic device only provided, and this programmable logic device, remember in your mind. Here we can be able to store. Here we can be able to store the information. So don't forget. And so here microcontroller is available in different word length like microprocessor, again 4-bit or 8-bit or 16-bit or 32-bit or 64-bit up to 128 bit we have. Okay, so 1 bit equal to how much bytes? 8 bytes. You have learned in your digital system 1 year back, bits and bytes. I hope you remember. I don't want to go into that. So you have learned Boolean algebra, ones and zeros, and gates and other things. There you learned the difference between bit and byte, right? So 1 bit equal to 8 bytes, that you remember in your mind. So here the variety of microprocessors are available in the market in the terms of 4-bit, 8-bit up to 128-bit is available in the market as of now. So the next one will be, so any device that measures or stores or controls or calculates or displays information must have a microcontroller chip inside. So very, very important point. Any device today, that's why actually I told you display devices. I told you many display devices. Not only display devices, a device which is used to measure any parameter, measuring a voltage or current, or measuring a torque or any values, uh, and store the adequate amount of information. Uh, when we wanted to store the information, see, the storing is much important here. The previous case which you learned in microprocessor, we don't have a capacity of storing. Try to understand, that's a major difference between there and here. There you can able to program it, you can able to run it, and you can able to interface it, and you can able to execute it. But whereas here you can able to store the information. Suppose if there is a power interruption or power failure or anything, again you have to restart with your microprocessor. Whereas here you can able to maybe the informations or the programmed codings will be stored. Uh, Therefore, once the power comes, immediately you can start where you left. So like that, you have a option you have. So any device today, variety of devices are available in the market and the society. All as of now, daily we are seeing many measuring devices. You all know the meaning of measuring length, measuring distance, measuring a voltage, measuring a current, or measuring any analog informations, or measuring certain unknown parameters, and storing certain information. Storage in the sense of whatever information visually see or visually recorded, that everything will be stored in the device itself. Okay, so right now I'm taking class to you people, and you people are attending. This information is also recorded here. That means it is stored in my computer. And control. What do you mean by control here? See, to control the various parameters like temperature or moisture or humidity or vaporization, or to control any movement. For example, if you design a robot, there you need a control to a robot to the movement, a right forward movement or a backward movement, or left or front or right, or whatever may be. So that controlling parameter to control certain limitations, to control certain constraints. Uh, Next one is calculating various values, calculating the unknown parameters, calculating the design values. Everything. So whatever you are calculating, that calculating or displays information must have a microcontroller chip itself. So I told you the first point, microcontroller already we discussed as a chip, and it's a programmable logic devices which are able to store the information, and also you can able to retrieve the information that you don't forget it. So here a device which measures or store or control or calculate or display any information, that information will definitely in that particular equipment or module you may have a microcontroller chip inside. Next point is the largest single use of microcontroller is in automobile industries. See, automobile industry almost comes under our area only. See, in India, mechanical, mechatronics, or automobile and aerospace, these are all comes from that mechanical engineering only. These people only will have a wide opportunity to the later subdivision. Earlier we have mechanical engineering. Then the later part they just split into aerospace and automobile. In later part, by incorporate, the moment they started using the electrical and the electronic devices into our mechanical system, therefore we converted a system called mechatronics engineering. You understand? So thereby, automobile industries also used by using various type of microcontrollers. You know very well, automobile industry in the sense here they are speaking about the latest amount of car. And, we all have latest amount of cars, right? Earlier, see, maybe some 20 years or 25 years, maybe your parent may have an old basic car like the Maruti 800 or Ambassador car. Have you heard about Ambassador car? The old model. So there the gearing system, the clutch pattern, everything is something different. But nowadays you have a gear type systems are very flexible and easiest way. You may say that hydraulic type or pneumatic type, maybe various type, maybe you have come across in your basics of your mechanical. Maybe in the earlier days, the first 2 years, maybe you learned many mechanical devices. You may say learned about the pneumatic system, hydraulic systems, and everything. So like that, we had earlier systems. So nowadays we had automobile industries with the latest amount of equipment and manufacturing and other things. So remember in your mind there, right now in your car with a lot of latest amenities like keyless entry. You need by pressing our key to a remote location, we can open our car. And while driving, suppose if you unfortunately if you met any accident or anything, our APS system with the sensors and the balloon formation, immediately we can safeguard, provided uh, earlier if you face any accident, immediately 100 people will be died, right? Very often we used to see. But nowadays, in many sophisticated and the latest technology and the latest facility which is incorporated in the car in the form of microcontroller chips are now safeguarded by people. Certain accidents and all the people will be escaped. We very often used to see it in the news or in paper or WhatsApp. All the people are escaped by you helping the ABS system. How this ABS system, everything is worked. All the sensors are incorporated across the body of your vehicle, and inside the sensors, definitely you have a microcontroller chip. So with the help of your microcontroller, basics of microcontroller chip only, it is used in the automobile industry. So today's many computing part, many industries, many latest sophisticated facilities which are incorporated into any system. Remember in your mind, everywhere we are using the basic idea of your microcontrollers. Maybe in the later part you may speak it as embedded control, or some modification might be happened in your controllers. Right? So the objective behind is control. You learned a basic control about PID control, PR, proportional integral and derivative controls and other things. Now you are learning microcontroller. Later part you will be learning ARM controller. Then finally you will learn embedded based controller. In future, when the moment you complete your degree, you will speak about some more variety of advanced controllers with other names. Controller operation and basic remain same. Latest minute changes which incorporate or which help the society to do some certain new facilities towards our system, that only speaks the new invention here. That you remember. So today's scenario, automobile industries are placed a vital role with the help of your microcontrollers. You all know that many later, even you in your two, everyone have your two wheelers, right? You are all the backup of mechanical students or mechatronics students. You are also almost like a mechanical or mechatronics engineers. You people know how to ride your bike and other things. Now many of you did not use your kickstart. You may not use your kickstart. Instead, you go for the easiest way like auto start. How the auto start everything is working. Auto start everything based on this microcontroller and this chip design. You could understand. So remember in your mind, this automobile industries and all the vehicles nowadays we are using everything. We also live it in this world in a we wanted to do all the tasks in the easiest way. We don't want to waste our time. We don't want to spend much time. We wanted to complete all or amicably complete all the tasks within the stipulated time and stipulated area within the stipulated period of moment. That's why this type of involvements or this type of enhancements in the technology sides are helpful towards this type of device. So here automobile industries and also controlling the engines and power controls in your automobile. And our next one is you can also find the microcontrollers inside your keyboard, whatever wherever you are using the keyboard. Keyboard in the sense don't ever immediately think about your laptop or your PC or anything. There are variety of places keyboards are using, right? Various places in their before their display devices, they may have a keyboard system to enter the values or to retrieve the values or to type the values and other things. And a mouse, you know the meaning of mouse, and you know the things of modems. Then uh, printers, you all have variety of printers, and nowadays do you know that you all have advanced printers. See, I have a printer, I have to connect to my laptop or my PC, then while interfacing only I can able to take. Now you people now may have a advanced printer saying that from your mobile itself you will have a command, your mobile through net you may be connected in your printer or through Wi-Fi it may be interfaced. From your mobile itself you can do the printing option and you can be able to get the printing documents nowadays. See, earlier by connecting our system from that system only we can able to get it. Now everything is stored in your mobile, right, in the form of data in your email or in your Google Drives. Many adequate information are stored in your mobile, almost like your computer, whatever capacity it has, a disk it has, the same amount of GB. Now you have it in your mobile phone also. So just imagine, mobile is in a single, a very simple format. at least even in your system occupies at least 2 by 2. Whereas your mobile occupies by you can keep it in your pocket. So there it stores a lot of amount of energy by using your mobile by interfacing or by connecting your printer through your mobile itself. You can able to now get the printout and other things, the latest printers. So there also we are using microcontrollers. Then in test equipments, microcontrollers make it easy to add features such as the ability to store the information or to create or store user routines and to display messages and waveforms. See the display messages and waveforms in the sense in the laboratories. In the laboratories, while we go for any testing in any laboratories, maybe in your mechanical labs or in your automobile labs, in our machine level labs or electrical labs or mechatronics and labs everywhere, certain characteristics or certain parameters are displayed on the screen, maybe in the form of oscilloscope or any other storage oscilloscope anywhere, or the PC which is interfacely connected. You can see the waveform in the screen, right? You can able to continuously see the waveforms in the screen. That every routine values are working based on the help of all the display informations, and the same informations can be able to store. Sometimes maybe in the certain laboratories, in the display, whatever waveform you used to see, that is the trap, and you will take the printout in the laboratory itself and you will keep it in your records, right? So earlier, when I was a student, we cannot store such information. By visually we can see, and we have to draw the thing on a graph sheet and we will just paste it. Now, you people will have a facility to print that option. Are you able to understand? See, the 25 years back when I was doing my engineering, situations are something different. Visually we can see, then we have to same structure we have to replicate it in the manufacturing sheet. But whereas now you people we cannot replicate anything. The moment you start seeing the information or the stored information or the display information, that everything will be stored in a particular drive. Whenever it is necessary or whenever it's needed, you can take the printout. So that type of options you people have. And consumer products that use microcontrollers include, especially we have this digital camcorders. There are a lot of digital cameras, digital camcorders, digital recorders, then your drones and optical players, or whatever the optical devices we have, optical players, then LCD, liquid crystal display, as I told you earlier, then LED, light emitting display devices, etc. These are all just a few examples. You remember, whatever we are discussing, everything on a few examples only. There are n number of applications, n number of devices, n number of equipments are connected with the help of a chip called microcontroller on a daily day-to-day applications in our life. In our current scenario, you may come across that, but we might not experience all those things, right? See, we used to think about certain things. We may not think certain things in an elaborate manner. So, this is the basic applications in the daily day-to-day routine in many areas. So consumer products like microcontrollers, digital camcorder, optical players, LED, LCD, even your latest mobile phones and your latest uh, cameras, everything, all controllers based on your microcontrollers. So then the lot of smart devices are available nowadays. So you are saying that smartwatch, and there also you have a display, right? So there also you have option of the basic controller of microcontroller options. See, that's why yesterday's class I stressed you again and again. You people will have a wide future on the forthcoming days. You people will have a glorious days in your future. Yeah, I don't know how many I will see. Maybe in person, the moment we started meeting each other, I'll come to your class and I'll talk to you how the rate of scope in the society on mechatronics engineers in the future. See, you are not just an engineer, you are a multidisciplinary engineer, remember in your mind. Remember, remaining all engineers, they will focus only on their own domain. Mechatronics engineering in the society is a new area where people are focusing on multi-talented research. And nowadays, I'll ask you one simple question. I told you one word, mechatronics engineers will have a more glorious time or more wanted in the society on the forthcoming days. I told you, not only forthcoming days, nowadays, as of now. You may ask a question, why? See, nowadays, do you like it? Anywhere if you go? Do you like a person who is doing on a single work, works on a single place or a single manner you like, right? We, the living society in this world, currently we have that type of mindset only in the world. That means, remember my mind, uh, we need to have complete all the multi type of different type of task, different type of work on a single place within a stipulated time. Time is oriented and many tasks have to be completed. That can be done by electronics engineers who are learning electrical, who are learning electronics, who are learning computer science, computer programming and computer coding. Then also you are learning your mechanical basics. Mechanical, automobile, aerospace and machinery things are your fundamental. Along with that, you are incorporating that ideas into in the form of electrical, electronics and computer. Thereby you are interfacing. That interfacing devices is nothing but your microcontroller that you remember in your mind. You able to understand? So consumer products that use microcontrollers include your digital camcorder, optical players, LED display, LCD display, everywhere. These are all the basic examples. So that's why I told you in future when they wanted an engineer, they don't want a unique engineer. They want a multi-talented, multi-wide task-oriented, multi-awareness engineers they wanted. You need to understand. That's why mechatronics people will have an ability to work it in the field of electrical, electronic, mechatronics, mechanical, aerospace, automobile, and all the development oriented software side also you people can work. Just imagine being a mechatronics engineer, how wide you are going to, how the society, how the industries are going to use it in a multi-different field. That's why you people are called as multi-oriented research engineers. That you remember in your mind. Maybe your HOD or your teachers may have discussed to you earlier, but still, as a teacher, long period in the engineering field, I just wanted to tell you some because sometimes you are making the sixth semester. Many of you do not know by somebody's advice or somebody's force you may be taking mechatronics and still you do not have a hope. Remember, try to have much confidence and hope on this area. This area only will dominate in the world on the forthcoming days. Will dominate the society on the forthcoming days in terms of product oriented or product designs. So now, so far we have just discussed about the basics and the necessity of a microcontroller. Now this is the reality of a micro. I told you it's a chip, not it's a. This is the real structure of a microcontroller. So here, let me check whether the connection is discussed. No problem. See, in morning class, one class where I was taking the last 5 minutes, the connection were disconnected. So I just parallelly checked it. Because right now I'm in the sharing mode. So I do not know exactly whether you people are connected. That's why parallelly I just checked. Okay. Now this is the outline structure of your microcontroller. So you have a VCC. Then VCC indicates your supply. And the GND indicates your ground connection. And you have CPU, timer circuit, oscillator. CPU is like a central processing unit, what you are speaking in your computers. The same thing here also, you have a processing unit, you have a option of storing the device. And just in the center part you see memory. You have two type of memory, one is random access memory and another one is called read-only memory. And there only you have the two options, EEPROM and EEPROM. Erasable programming of your memory. One is the one part is you can able to erase or you can able to store the programming options. So that will be bi-directional. So both the things will be the memories will be read-only memory and the random access memory, or both are in bi-directional directions given. And oscillation circuit here used to generate a signal. So in the oscillator circuit you have a crystal is given. So a crystal may be in various form, quartz crystal or piezoelectric devices or piezoelectric materials may be used as a oscillator design. And in the special functioning block, it's generally it's given special functioning block. There only you have what sort of functions to be carried out or to execute by a microcontroller will be programmed along with your pins and the ports. And in the below part, you have counters and the interrupt control. Timers and counters. Timers in the sense, it speaks about the continuous involvement or the timing of the network. Counters are used to give the timing, each count or each operation when it will be has to be performed. Final one important thing is, yesterday's class also I told you, the data or whatever data you are programmed or you are processed here through the devices or through your input supply and your operating special functioning block. Finally, it has to be converted either in the form of analog to digital conversion or digital to analog conversion. That is much important. Yesterday's class I told you we'll have a case study. Uh, you have already learned what is analog to digital conversion and digital to analog conversion with the help of gates you have learned, or gate and NAND gate you have learned. So here in terms of analog to digital conversion or digital to analog conversion, by programming you will see by interfacing a microcontroller device how an analog data is converted to digital and the digital data is converted to analog. So this is the general outline, basic structure of your microcontroller. By visually, this is the. But if you see your chip will be a micro level chip. But inside, how much things we have categorized. In a microcontroller, we have a oscillator circuit, we have a timer circuit, we have a counter circuit, we have an interrupt control. Interrupts are giving sequence of interrupt to any devices within a substantial gap of time. And finally, you have a parallel input and output ports. So you have an input port as well as you have an output port. So both of the things are essential for any devices. The certain information you may give through input ports and certain information you may retrieve through your output ports. So this is the general structure of your microcontroller. In general, this is how the microcontroller structure will be. So remember in your mind, in your microcontroller, you will have A to D or D to A conversion, timers, counters, interrupt, parallel input output circuit, or a functioning unit, and you have a memory. So that is the blue color letter. That is very important. In your microprocessor, you have a memory, but that memory will not be stored, as I told you earlier. But here, your memories can be erased or your memories can be stored and your memories can be retrieved. You can be able to retrieve the data. So this is the general layout of your microcontroller that you remember in your mind. So these are all the functioning blocks in general we have. So when you go for an advanced controller, some of the blocks may be changed. Some of the block ideas may be changed. Some of the trapping ideas may be changed. Some more parameters may be introduced. So like that. So this is the general outline of any type of microcontroller. So 10 power 6 is a micro. So this microcontroller structure will have, the important thing is you have a memory options, so you can be able to store the devices. So in the next class, we will continue with this from microcontroller structure to the other things. So now the time is almost 12:23, and you are also running out of shortage of time for your lunch and other things. So you now you give just a minute. You'll be online. Let me take the attendance, and now you can do. So in today's class, we just started with your microcontroller introduction. Yesterday's class, the overall view we have discussed. Why we are learning the paper, what is the objective behind the paper, and what is the outline, outcome behind the paper. See, whenever we wanted to learn something, we should know why we are learning. Without knowing that, what is the use of learning as an engineer? Being an engineer, we should think about what is the objective, what is the outcome. Without that, don't learn anything. Are you able to understand? So that's why today's class fully we have discussed about the entire thing. And in today's class, we just start according to your syllabus. We just started with the 8051 microcontroller. So every display device, remember in mind, every device or display devices or every the devices which have the property of displays or displays much information, latest applications, everything on the role of your microcontroller. It's a single chip. And finally, we saw the structure of your microcontroller, the basic general structure. Mainly, we have a memory when we compare with your microprocessor. And here, 4-bit, 8-bit, and 16 up to 128 bits are, as of now, it's available in the market. Up to that, we have discussed. And this is the general outline of your microcontroller. In the next class, we will discuss about the remaining part. So, be online. Now, let me take the attendance. Guys, for just 2 minutes, I will take a snapshot and Okay. And the chat box, I hope I think Vishnu has connected all of you in my WhatsApp. So he has created a WhatsApp and connected, so no issues. So any other things, if you want, by literally you missed the hour, you just send your names and your register number so that I will mark your attendance. Don't be delayed. Okay. The day itself, you immediately you post that so that only I can able to give your attendance. Nothing else that. So in the next class, we'll continue with the remaining topics. So now have a nice lunch and now you can leave. Thank you very much for all your patience in the end of the session. Okay, thank you
Thank
guys.
you, sir.
Thank you.
Thank you,
Thank
sir.
you, sir.
Thank you.
Thank you,
Thanks,
sir.
sir.
Yes, you can leave. Thank you.
Thank you, sir.